Hello, today we'll talk about a new interesting topic which is called dimensional analysis, or it has another name which is called factor label method. Indeed, dimensional analysis is not difficult. It's just a multiplication of several fractions in which you have to put the fractions such a way so that all the same units just cancel each other. So at the end you will get the unit you need. Third thing that you should know is the conversion factor. The conversion factor is used for converting one unit into another unit. Conversion factor is a factor which is equal to 1, but in the numerator and the denominator there are different units of the same quantity. I will give you an example. For example, if we are talking about volume, 1 liter equals to 1000 milliliters. So we can write a conversion factor like this: 1 liter divided by 1000 milliliters, or we can write it like 1000 milliliters divided by 1 liter. This will be a conversion factor because, as we see in the numerator and denominator, we have the same quantity, 1 liter or 1000 milliliter, the same thing, but the units are different. For example, now let's say we need to convert 2.5 liters into milliliters. What we have to do? We have to multiply it into such a number so that in the denominator we have liters, so that liter and liter could be cancelled, and in the numerator we should have a milliliter. So we look 1 liter and 1000 milliliter. When we see liter is 1, so we write here 1 liter. In the milliliters we put 1000, and the answer will be 2500 milliliters. It's the same as we multiply 2.5 by 1000, because we know 1 liter is 1000 milliliters. So for converting liters into milliliters we just multiply by 1000. The idea is the same, just here we use a conversion factor. We get the same result. Now let's take an example, one problem, and let's solve it using dimensional analysis. Let's write first what we have. So let's write the given data. So what we have from the condition of our task, we know that we need to get a solution that will have a final volume 750 milliliters. So the final is 750 milliliters. Concentration of the final solution will be 0.150 molarity. What means? What is molarity? It's mole divided by liter. We can write it in this form. Then we also can write here molar mass of sodium hydroxide. If we look from the periodic table, it will be 40 gram per mole. Well, this is the information for the final solution that we are going to obtain. But we have also the stock solution. What about the stock solution? It's given that its mass fraction is 40% by weight. It means that in 100 grams of solution we have 40 grams of sodium hydroxide. The density of the stock solution is given 1.70 gram per milliliter. We need to find the volume of the stock solution. Right. This is the data that we have. Now we start solving the problem. Let's use dimensional analysis method. What we need? We need to find the volume of the Stokes solution. And let's see what we have. We have 750 milliliters of sodium hydroxide, yes? 750 milliliters. So we write here 750 milliliters of sodium hydroxide. We multiply it. Now, what can we multiply it? To such a number which has in denominator milliliters volume, okay, so that milliliters could be cancelled. Indeed, we can multiply it by the concentration, 0.150 mole per liter, multiplied by mole per liter, 0.150 moles in 1 liter. And now we see that here we have milliliters and here we have liter. Milliliter and liter. We have to convert liters into milliliters. We know that. To convert liters into milliliters, we multiply by 1,000. Like 1 liter, 1,000 milliliters. So we use the conversion factor here. We multiply by the conversion factor. In the conversion factor here, we write the given unit so that this one and this one could be cancelled. Okay, here we write the desired unit. For as liter, 1 liter and 1,000 milliliters, 1 and 1,000. This is what we do, and let's see what happens here. In this case, liter and liter are cancelled. Then we have milliliters here and milliliter here are also cancelled. We have mole. We now have to multiply it into something that will have mole in denominator. Mole. So we will have moles also cancelled. This mole and this mole will be cancelled. But what could it be? Indeed, it can be the molar mass. If we look at the molar mass of sodium hydroxides, 40 gram per mole. So it means that in 1 mole we have 40 grams. So moles cancelled each other. After that, we multiplied by what? Let's see what we have. We finished. We used all this data. Now we have omega, which is 40%. 40% means that in 100 gram of Stokes solution we have 40 grams of sodium hydroxide. So these grams here will simply cancel each other. We need to cancel it as well. How can we do it? We need to get it. We are looking for the volume, if you remember. Yes, volume of the Stokes solution. The answer must be in milliliters. So what we need to do, we need to multiply it to such a unit that would have gram here in denominator and milliliters here, so that this gram and this gram could be cancelled and milliliters would remain, and that is, you see, the density, 1.70 gram per milliliter. In 1 milliliter we have 1.70 gram. Let's see. So as you see, I will return it back. As you see, when we pay attention on this, all the units cancel each other. So you have to write the multiplication of this fraction in such a way when the units cancel each other, and at the end we get the desired unit. Finally the answer will be, if we do this calculation, the answer will be 7.5 milliliters of stock solution. I will write SS, stock solution. But now I will show you another method, step-by-step method, how to do it. The idea is the same, that is the dimensional analysis, but when you can do it step by step, and then it will become more clear what dimensional analysis is, and then I will give you a comparison of these two methods. Step 1. Step 1, so A. What we do? We have to find number of moles of sodium hydroxide. We know this formula, N equals CV. Hence, number of moles of sodium hydroxide will be the concentration is 0.50, volume is 750. So we multiply them. 0.150 mole per liter multiplied by 0.750 liters. And the answer here will be 0.1125 mole of sodium hydroxide. Part A. Then B. We know the number of moles. We can find the mass of sodium hydroxide. We know the formula N equals M by molar mass. Number of moles, we found it. This is the number of moles. Let's write it here. Multiply the molar mass, as we said at the beginning, was 40 gram per mole. As the result, here we will get 4.5 grams of sodium hydroxide. Let's go now to the step 2. We found that we have 4.5 grams of sodium hydroxide. These 4.5 grams make up 40%, because it is given that in the stock solution we have 40% of sodium hydroxide by weight. So let's find the mass of the solution. We know that omega is equal mass of sodium hydroxide divided by the mass of solution, stock solution, multiplied by 100%. So from here we can find the mass of solution. Mass of stock solution will be mass of sodium hydroxide, as we said, it's 4.5 gram, divided by, multiplied by 100% and divided by 40%. Or we can simply divide it by 0.4. And when we do these calculations, the answer will be 11.25 gram of stock solution. So now we know the mass of stock solution. We can find its volume. Our purpose is to find the volume, right? We can find the volume of the stock solution. Step 3. We have the density. With the mass, we found that the mass of the stock solution is 11.25 gram. The density is given. It was 1.5 gram per milliliter. So we can find volume. We know that density is M divided by V. Hence, to find V, we can divide M by D. So volume will be mass divided by 1.5 gram per milliliter. The answer will be 7.5 milliliter of stock solution. So we get the same answer with this method. Now I will show you like this all written on one page, where you can see the comparison